All right, in this lesson, we're going to look at the probability of a false negative given a drug test. Now, even though we're focusing on the circumstance of a drug test, you can also apply this same procedure to tests of diseases like a COVID test or other kinds of tests like that. So if you want to see my introduction to false positives and false negatives, I do an introduction in my video on the probability of a false positive. But now we're just going to jump right into the examples of false negatives. We've got an employer that requires all job applicants to take a drug test. Statistics indicate that 6% of all applicants actually use drugs. So we're gonna start off a tree diagram here, and we're gonna start it off with a 1 meaning 100% of all applicants. And we can split all applicants into two categories. Those that are drug users, we're just going to call them users, and then those who are not drug users, we're going to call them not users, okay? And it says here that 6% are actually drug users. So 6% can be written as 0.06. That's as a proportion instead of a percentage. So not users is going to be 1 minus 0.06. And if you did that in a calculator, you would get 0.94. So 0.06 plus 0.94 is 1. And that means that 94% of the applicants are not drug users, okay? But it says here, it says that the test itself correctly identifies drug users 93% of the time. So 93% of this 6% will be correctly identified. That means testing positive. Testing positive means testing as a drug user. So positively identified as a drug user, 93% of the 0.06. So we're going to need a calculator for this. We're going to do, let's see here, we're going to do 93%, that's 0.93 times our 0.06 proportion of drug users. And that's 0.0558. So we're going to put a 0.0558 here. And then the rest of the drug users were actually tested negative. They tested as not drug users, which is a mistake. And so that makes them false negatives. So we're going to do 0.06 minus 0.0558. So 0.06 minus 0.0558, and that gives us 0.0042. So 0.0042, okay? So 0.0042 of all the drug users, which are 0.06 of all of the applicants, were incorrectly identified as not drug users. Now let's split up the not users into those that test positive, which unfortunately happens sometimes. That's a false positive. And those that test negative, and that's a true negative. Okay, so they're not users and they test. They're not users and they test negative for drug use. Okay, it says here, however, the test incorrectly identifies non-users as drug users 2% of the time. So 2% of this 0.94, that's 0.02 of them. So of the 0.94 times 0.02, 2% of the 0.94 that are not drug users are actually going to be identified as drug users. That's 0.0188. So 0.0188. And then for the rest of the people who test negative and are actually not drug users, we're going to do 0.94 minus 0.0188. So 0.94 minus 0.0188. So that gives us 0.9212. 0.9212. So 0.9212 of the applicants are actually not drug users. They are actually not drug users, and they test negative for drug use, which is good. That's a true negative. These guys up here, the 0.0558, they tested positive and they are drug users, so they are true positives. But right here, these are drug users, but they tested negative. These are false negatives, And then these here, these are the false positives. Well, we're being asked about false negatives. We're being asked, it says, what is the probability that an applicant tests as not a drug user? That means they're testing negative. So that's here and here. That's this group and this group. But actually is a drug user. So what we're being asked for here is the probability that somebody is a user given that they test negative. Okay? And so we want all the people that test negative in the denominator. So that's going to be 0.9212, 0.9212, plus these people also tested negative. That's 0.0042, 0.0042. So that's the denominator. And now the numerator is going to be the people that are drug users. They are drug users, but they tested negative. Users testing negative, that's 0.0042. And we're going to put all of this into the calculator. Okay? So we're going to do 0.0042 divided by parentheses 0.9212, 0.9212 plus 0.0042, 0.0042, close parenthesis, execute, and we get 0.0045, and it says round to 4 digits, so 0.0045 is our final answer, equals 0.0045, and it says round your answer to 4 digits, and so we're going to put in 0.0045, okay? Let's do another example. All right, here's the same situation again. It says an employer requires all job applicants to take a drug test. So we're starting with 1. Okay, so we'll put a 1 here, and then over here we'll put the users. And down here we'll put the not drug users. We'll say not users. Okay, and it says it correctly identifies drug users 93. Statistics indicate that 5% of all applicants actually use drugs. 5% is 0.05, so then 95 are not users. That's 0.95. 0.95 plus 0.05 equals 1. Then it says the test correctly identifies drug users 93% of the time. So we're going to identify 93% of this 0.05 as, so positively, as drug users. The other 7% are going to test negative, and so that would be a false negative. So we're going to take our 0.05, multiply it by 0.93, and we get 0.0465. 0.0465. Then we're going to do 0.05 minus 0.0465. So 0.05 minus 0.0465. And that leaves us with 0.0035. 0.0035. Okay? Now we're going to go to the not users, the 95%. We have 2 categories here, those that test positive erroneously, and then those who correctly are tested negative. It says, however, the test incorrectly, that would be not users that test positive, incorrectly identifies non-users as drug users 3% of the time. So we're going to do 3% of the 0.95. So 0.95 times 3%, which is the same thing as 0.03, and that gives us 0.0285. So we're going to put 0.0285 here. Then we're going to do 0.95 minus 0.0285. 0.95 minus 0.0285. And that gives us 0.9215. 0.9215. Okay? And then it says, what is the probability that an applicant tests as not a drug user? Okay? So that's the probability that they are given not a user. So out of all the people that test as not a drug user, but is actually a drug user. So what's the probability that they are a drug user given that they tested as not a user? Now remember, we're going to put these in the denominator. All of the not users, all those that test. sorry, they test, I meant to say test, not user. Let me fix this. I meant to say test negative is what I meant to say. So let me redo this. Okay. What's the probability that they test negative? There we go. They're a user given that they test negative. So we're going to put all the test negatives in the denominator. So that's 0.9215 plus these guys tested negative also. That's 0.0035. And then in the numerator are the people that are users. They're actually drug users, but they tested negative. So users that tested negative, that's 0.0035. 0.0035. And now we're going to go back to the calculator. And we're going to do 0.0035 divided by parenthesis 0.9215 plus 0.0035. Okay, and then hit execute, and we get 0.00378. This 8 is going to turn that 7 into an 8, so the answer is going to be 0.0038. So it's 0.0038. And sure enough, it says round your answer to 4 digits. So we're going to do 0.0038. Okay. Let's do one more example, but we're going to do it with the question in a different form. All right, so look at this example. We'll read it in a second, but look, we go all the way to the bottom, and here's what it's asking. It's asking us, what is the probability that they tested negative, but they used drugs? And that's the same as what we've done in the other 2 examples, okay? It says an employer requires all job applicants to take a drug test. The tree diagram below is used to summarize the probabilities of testing positive or negative for drug use based on whether an applicant is a drug user or not. We're set up the same way. We got a 1, we got users up top, non-users on the bottom. So let's go ahead and rewrite this. So we have 1 splits off into users, okay, and non-users, not users, okay. It says right here is the letter A, and A is 0.061. So we're going to put a 0.061 here. We're going to do 1 minus 0.061, and that gives us 0.939. Okay. Then we're going to split off the users into those who test positive and those who test negative, because that's what it says here. It says testing positive goes up top, testing negative goes down below. This number here is B, and B is 0.046, 0.046. And to get this number, we're going to do 0.061 minus 0.046. So 0.061 minus 0.046, and that gives us 0.015. So here we're going to put 0.015. Then the non-users, we're going to split them up between those who test positive and those who test negative. And those that test positive are going to be letter C here, and that's 0.028. So 0.028. And to get this number down here, we're going to do 0.939 minus 0.028. So 0.939 minus 0.028. And that's going to give us 0.911. 0.911. Okay? And so now it says that we want to know, well, what's the probability that an applicant tests as not a drug user? So they test negative. All right, so the probability that they are, but it says, but is actually a drug user. So the probability that they are a drug user given that they test negative, okay? So we're going to put in the denominator, we're going to put all the people that test negative. Well, here's negative and here's negative. So we're going to put the 0.015 and the 0.911. So we're going to put 0.911 plus 0.015. And in the numerator, we're going to put the people that are drug users and test negative. So they're users and they test negative, and that's 0.015. So 0.015. And so we're going to put this in the calculator. 0.015 divided by 0.015 divided by parenthesis 0.911 plus 0.015, close parenthesis, execute, and we get 0.0161, and then this 9. This 9 is going to make this 1 a 2, so it's going to be 0.0162. So it's going to be 0.0162. And so that's what we're going to put here, 0.0162. And that's a third example of the conditional probability that the person is a drug user, but they test negative, and we call this a false negative. It's a negative because it's a test negative. It's false because it should have tested positive.